Hello folks, this is an addendum to a tutorial that I already prepared in the playlist that is indicated here. The playlist is called uh, Elementary Structure Analysis Problems with 3D Experience, and it's tutorial one. And I made a claim there which is not true. And in fact, it was brought to my attention by this gentleman down here. There, I mentioned that there are some issues with the beam with a general section profile, okay? And it's not working. So anyway, let me go ahead and explain to you what the issue is. When you do beams, you can obviously uh, specify the profile uh, by this icon. That's what you have to do first. You can make it rectangular, circular, trapezoidal, etc., etc. And there is also an option which allows you to say, okay, I'm not going to give you the profile shape, but I'm giving you the properties that you need. In other words, the moment of inertia that you need about the local axis of the cross section. And then you work it out. Okay, so there is no profile per se is specified, but it's called general profile, and you proceed from that point on. And so let me show you what is involved when you do that. First step is once you create your geometry, which is just essentially a line or a wireframe or something like that. You have to select the I-beam profile, and when you do that, you have many options. But if you don't want to give it any of these, except that you want to specify the property, you click on the general, and on the general, you have to specify several things. Well, first of all, the coordinate systems 1 and 2 are the coordinate system in the cross section, okay? And there is area, of course, needs to be specified. And there is a second moment of area about this axis, about that axis, okay? And the product of inertias, uh, which indicates that the beam is obviously symmetric, has a symmetric cross section, is going to be 0. But anyway, it doesn't have to be symmetric. And then you also have to give you the torsional inertia, which uh, it could be that it's the sum of I11 plus I22, but it doesn't have to be. Now, these things are not needed. So what I noticed in tutorial one, or claimed in tutorial one, is that although you can specify these things, but you cannot pick it when you try to specify the cross-sectional or beam uh, properties, 1D beam properties. Okay, it turns out that when you try to specify the beam section properties, if your profile is general, this checkbox, this obscure checkbox, has to be checked. Of course, when you read it carefully, it says that choose this option when numerical integration over the section is not required. And that's pretty much what we're doing when we're giving it the value of I11, I22, and I12, etc. So the claim that I made there, it is either not implemented or uh, yeah, so that is not true. It was there, it's just that I didn't see it. Okay, so what I'm going to do is do a problem where for area I specify this, I11 there, I12, I22, and J. Now, when you look at this thing carefully, essentially this is a beam with a square cross section of size 1 by 1. So the area becomes 1 by 1, which is 1 inch squared. The cross section about uh, the axis that goes through the centroid, I11, is 1, remember, 1 over 12 BH cubed, but B and H are both 1, so it becomes 1 over 12. And the other one where the bending is not taking place is also the same thing because it's a square. And because it's symmetric, I12 is 0. And finally, J, which is for our case, is going to be the sum of these two, is going to be 1 with. So I'm not going to use the fact that it is actually a square cross section, but I'm going to say, oh, these are the properties that I want to use. And how do I check whether I've done it right, or through the experiences FEA solver, which is quote unquote abacus program, is spelling out the correct value? I look at the tip deflection, and it should be 0.13333 inches. I'm assuming that the properties of steel are used here. So let's go ahead and work this out. We go here. I'm in part design, so I'm gonna make a line, 10 inches long. So line, okay, and point and direction. For point, I'm gonna make 0.000, okay, and say okay. And the direction, I'm going to extend it in the y direction, 10 inches. Okay, good. Now, because because this is a in general, if you have a non-circular cross section, you need an orientation point. And it is also the case that for a general section, you need an orientation point, because otherwise it won't let you close that box. So I can do it now, or I can do it later. Either way. So what I'm going to do is I'm going to create my orientation point now. Otherwise, I have to come back here and create an orientation point. So I'm going to say a point. I'm going to make it off this. It has to be off that axis. It cannot be on the continuation on it, etc. So let me make this thing maybe just for visual purposes, so I can see it, 2 inches in the x direction, right there. There's a point here. If I don't make this point, or if I don't make a point for the specified orientation, when I try to apply the beam section, uh, it's not going to take it. You're going to get an exclamation mark here. As a matter of fact, uh, I created this point, but we'll worry about it later on. Now, let's go ahead to tools. uh, I'm gonna make a material steel. So steel, I'll put down October 12, 2024. Okay, it's gonna make it, and then I have to put in the numbers in there. Okay, right there. So I'm gonna take this thing, apply it to that part. Don't need these things, you can close them. I go to double click under structures, abacus multiphysics, mechanical, elasticity, elastic. Let's see now, 30 million PSI, or 30,000 KSI, either way. PSI, okay. And 0.3, although it's not needed, but anyway, 0.3. That's fine. So now we're going to go to the meshing module, which is one way is to structural model creation. And then say okay. It's an empty FEM. All right, so let's click on the mesh tab. That's a beam mesh. I select this, and I make it 1 inch size. So there's going to be 10 elements through the length. And I say mesh. So there's going to be 10 elements created here. Good, good. Now, we're going to go to properties. First thing that we're going to do is profile. We have to do beam profile. And the type is general. General. The values already told you what I'm going to use. 1 here. 1/12. Hopefully it'll take it. Yep. It doesn't like it. 1 over 12 is, okay, so let me see how else can I do this thing. What is 1 over 12? Use my calculator. It's point 0.8 something, but 0.08. Sorry, I should have done this thing earlier, but I forgot. 1 divided by 12 is 0.083333, etc. So I'm going to make 0.08333. Okay. This guy is 0 because the beam is the beam that I have in mind is symmetric, but I don't know that, of course. I put down 0. 0.08333. Okay, and this is going to be the sum of these two, so I'll make it, let's see now, if you double that thing, it's going to be 0.16, oops, space, 0.166666, okay. All right, good. Now, say okay. So a beam profile has been created here. There's no problem. And if I say update, for example, well, this may, let me see. Yeah. Okay, good. Let's go back here. Properties. Now we do beam section. So the support is that line. The beam profile is uh, oh okay, hang in there. One of the comments that I made here is that the profile does not even appear here. That's because this is not checked. Once I check this, that's the obscure checkbox. Now I get it showing up. That was a bad claim that I made, but there we are. Now notice that I can close this, but there is going to be an issue. You'll see why. I'm going to close this and show you what happens here. I check this box, selecting my profile, which is the general whatever, and then I say OK. So what happens under the properties, you get this exclamation mark. So it's not taking it. That's because you have to select the orientation point, which I already created right there. Now, when I do that, notice that when I do that, this is going to be direction, axis direction of direction 3, 1 and 2. These are the local directions. Okay, so we say okay. Now, if I update, Control U, see this exclamation mark went away. So it did take it actually. And when you do that, actually, you don't get any specific shape around that. You don't get any specific shape around this. It looks like that. Cross section looks like that. And if you want to actually, you can say display, and you select it as a sketch. It looks like this. This is not a circle, okay? Or not, or solid. It looks like that. This doesn't mean it's a circle, but that's the way it is. So none. That's okay. So notice that this is local direction 1 and 2, and this is the direction along direction of the beam, which is direction 3, which is fine. Now we move on. Let's move on to structural scenario creation. You select the FEM model. And we're going to do a simple static problem procedure. I can do a static perturbation, just a linear problem. Okay, so clamp this end. So under boundary conditions, clamp that end. Okay, and put a force here of can't remember what it was, 1,000 pounds. So we go on the load, concentrated force at this end in the direction Z. So it's going to be minus 1,000. And when I run it, I better get 0.133 inch deflection. Okay, so let's do it. Model and scenario check. No problem. And now I'm going to run it, and I should be getting 0.133 inch deflection. And if I do get, obviously that mystery to me is solved. It was implemented. It's just that that obscure checkbox had to be uh, selected. And remember, you need an orientation, but if you don't select that obscure checkbox, you don't even get the profile showing up in the list of profiles that you may have. Almost done. In the tutorial one, I also mentioned that you can't just randomly put those numbers in there. Certain condition must be met, otherwise you won't take it. So we say, okay, let's look at the displacement, 0.133 inches. Great, good luck.